This is TWiT.
We've never talked about the relatively recently formed OpenSSF. Hard to pronounce or say. OpenSSF stands for Open Source Security Foundation. It's a Linux Foundation project created in 2020 by a very large group of significant tech and financial firms with a charter to help steer, guide, and share open source security tools, which unfortunately are lacking. Its membership is divided into two classes, Premier and General members, with the Premier members in an alphabetical order being 1Password, AWS, Atlassian, Cisco, Citi, Coinbase, Dell, Ericsson, Fidelity, GitHub, Google, Huawei, Intel, IBM, JFrog, JP Morgan, Meta, Microsoft, Morgan Stanley, Oracle, Red Hat, Sync, Sonatype, VMware, and Wipro. And there are about 3 times as many general members, which I won't enumerate, but, many are equally notable. Like, there's Bloomberg, Comcast, Goldman Sachs, MongoDB, Spotify, SUSE, Tenable, Tencent, Carnegie Mellon, and MITRE. So, again, this is a heavyweight group. I also saw in some reporting that Samsung was a member, but they weren't listed on the group's official page. So at openssf.org, by the way. So that page, openssf.org, says open source software is pervasive in data centers, consumer devices, and applications. Securing open source supply chains requires a combination of automated tooling, best practices, education, and collaboration. And so they divide the effort that they're organizing into 3 components. There's working groups where they say collaborate on the planning, design, and delivery of security tooling and best practices that secure critical open source projects. Then they have town halls, stay informed about the latest happenings in open source security, and engage with experts in our community. And training, take free courses on secure coding practices as part of our Software Development Fundamentals Professional Certificate. So all of that is nothing but good. It feels like it's coming along a little late in the game, but wow, better than never. Okay, so that's the OpenSSF. We're talking about this previously undiscussed group today because last Thursday they announced the first results, which were a success, with some caveats that I'll discuss, of their project known as the Package Analysis Project. I've got a link in the show notes for anyone who's interested, but to introduce it, they explained package analysis, scanning open source packages for malicious behavior. And so they said, today we're pleased to announce the initial prototype version of the Package Analysis Project, an OpenSSF project addressing the challenge of identifying malicious packages in popular open source repositories. And, talk about something we've been talking about a lot recently, open source repositories. They said in just 1 month of analysis, the project identified more than 200 malicious packages uploaded to PyPI and NPM. Okay, so, think about that for a minute. Thanks to this project, 200 previously present but unknown malicious Python and JavaScript packages were found. In a minute, I'll share some of the details about what they found, but their announcement continues saying, the Package Analysis Project seeks to understand the behavior and capabilities of packages available on open source repositories. What files do they access? What addresses do they connect to? And what commands do they run? The project also tracks changes in how packages behave over time to identify when previously safe software begins acting suspiciously. This effort is meant to improve the security of open source software by detecting malicious behavior, informing consumers selecting packages, and providing researchers with data about the ecosystem. Though the project has been in development for a while, it has only recently become useful following extensive modifications based on initial experiences. Okay, so what they've built is a big heuristic engine which is capable of performing static code analysis, currently of packages residing in Python and JavaScript repositories. And as is the case with heuristics, which we can think of as, complex rules of thumb, tweaking and adjusting of weighting factors is typically necessary. But if the signals they're able to obtain from their static code analysis are strong enough, robust determinations should be possible. So they continue. The vast majority of the malicious packages we detected are dependency confusion and typo squatting attacks. The packages we found, they said, usually contain a simple script that runs during an install and calls home with a few details about the host. These packages, they conjecture, are most likely the work of security researchers looking for bug bounties, since most are not exfiltrating meaningful data except the name of the machine or a username, and they make no attempt to disguise their behavior. Still, any one of these packages could have done far more to hurt the unfortunate victims who installed them. So, package analysis provides a countermeasure to these kinds of attacks. They said there are lots of opportunities for involvement with this project. So they're also soliciting from, the community, and our listeners are part of that community. They said, and we welcome anyone interested in contributing to the future goals of, there are 4 of them, detecting differences in package behavior over time, automating the processing of the package analysis results, storing the packages themselves as they're processed for long-term analysis, and improving the reliability of the pipeline. They then finished, check out our GitHub project and milestones for more opportunities, and feel free to get involved on the OpenSSF Slack. This project is one of the efforts of the OpenSSF Securing Critical Projects Working Group. You can also explore other OpenSSF projects like SLSA, I didn't dig into what that was, and SigStore, which expand beyond the security of packages themselves to address package integrity across the supply chain. So, this is very welcome news. As we know, for the past several weeks especially, I've been lamenting the inherent lack of security of the systems that have been built to make sharing code libraries virtually effortless. The trouble has been that polluting these code repositories is also effortless. And recently, we've seen this process even being automated with bots to further thwart code identification and its takedown. I mentioned some specific examples from among the more than 200 malicious packages discovered during the first month of the system's use. The first 2 attacks listed in their case study, published on GitHub, were against Discord clients and their users. They explained that Discord attacks are focused on attacking Discord accounts or clients. They said stolen accounts can be resold, used for fraud, like cryptocurrency scams, or used to gain insider knowledge or secrets. The first one that was over on PyPy is Discord CMD. And in their analysis results, they said this Python package will attack the desktop client for Discord on Windows. It was found by spotting the unusual requests to raw.githubusercontent.com, Discord API, and ipinfo.io. They said, first, It downloaded a backdoor from GitHub and installed it into the Discord Electron client. Next, it looked through various local databases for the user's Discord token. It grabbed the data associated with the token from the Discord API and exfiltrated it back to a Discord server controlled by the attacker. And what's so cool, of course, is that they found this with automated scanning heuristics. The second Discord malware was over on NPM, and it was titled Color SSS. In their analysis result, they said similar to Discord CMD above, this NPM package attempts to steal a Windows user's Discord account token and was discovered by identifying calls to the Discord API. This package first searches through local browser databases for a token, queries the Discord server to discover details about the token, and exfiltrates the details to a Discord server controlled by the attacker. They also, during this first month of scanning, discovered a couple of remote shells. They explain, for those who don't know, a remote shell is used by an attacker to provide access to a command shell running on a target machine over the network. They're usually reverse shells that connect back to an attacker-controlled machine. So we have over on NPM, this one was Roku-web-core/Ajax, and they explained during install, this NPM package exfiltrates details of the machine it's running on, and then opens a reverse shell, allowing the remote execution of commands. This package was discovered from its requests to an attacker-controlled address. Another one in Python over on PyPy is ccrev3, and the analysis says this package opens a simple reverse shell when a specific module is imported from the library, allowing remote command execution. It uses a simple obfuscation technique to make it harder for a reader to notice. This package was discovered from the request to the attacker-controlled address. And lastly, over on NPM, this one was random-voucher code-generator. And they said when the library is imported, it queries a server running on their Heroku cloud platform. The server response includes a command and a flag indicating whether or not the command should be run. In the response we observed, the command stopped a process managed by PM2. However, they said, this same response can be changed to run any command the attacker wished to execute, including opening a reverse shell. The library then uses voucher code generator to provide the advertised functionality. So, you get your voucher code generator, but you'll get a reverse shell that you probably didn't count on. They said this package was discovered from the unusual request to the Heroku server. Their case studies page finishes by talking about dependency confusion and typo squatting, where they just, we've been talking about that recently, where, remember that dependency confusion, they did note that packages typically used a high version number. So the package managers that don't know better see that a high version number is available, higher than the one they have, and say, oh, I better go get that. And of course, when they do, they get themselves pwned. So not good. As we've covered previously, and I was just going to talk about exactly that the use of high version numbers in order to trick package managers into obtaining it. Google, who is an active participant in this effort, added a bit of additional background in their own blog posting. They explained, they said, despite open source software's essential role in all software built today, it's far too easy for bad actors to circulate malicious packages that attack the systems and users running that software. Unlike mobile app stores that can scan for and reject malicious contributions, and this is Google speaking. We know how tough even that is for them. Package repositories, they write, have limited resources to review the thousands of daily updates that must maintain an open model where anyone can freely contribute. Thus one of the big problems. As a result, malicious packages like UA-parser-JS, which we actually had spoken of previously, and Node-IPC are regularly uploaded to popular repositories despite their best efforts, with sometimes devastating consequences for users. Google, they write, a member of the Open Source Security Foundation, is proud to support the OpenSSF's Package Analysis Project, which is a welcome step forward helping secure the open source packages we all depend upon. The Package Analysis Program performs dynamic analysis of all packages uploaded to popular open source repositories and catalogs the results in a BigQuery table. By detecting malicious activities and alerting consumers to suspicious behavior before they select packages, this program contributes to a more secure software supply chain and greater trust in open source software. The program also gives insight into the types of malicious packages that are most common at any given time, which can guide decisions about how to better protect the ecosystem. Okay, so this is all for the good. The bad news is that this again puts us back into, I think, a pretty clear cat and mouse game. Because the project is inherently open, the bad guys can learn what the system is keying on and simply arrange to avoid it. How many times in those descriptions I just shared did we hear, quote, this package was discovered from the request to the attacker-controlled address, right? Or another of those, several of those descriptions said, these dependency confusion attacks were discovered through the domains they used, such as burpcollaborator.net, pipedream.com, interact.sh, which are commonly used for reporting such attacks, unquote. So the bad news is, once the bad guys learn that these simple factors, which did not previously interfere with their nefarious aims, have become problematic for them to use, they'll simply stop using such obvious targets by arranging to use non-obvious addresses, such as by proxying their connections through any of the gazillion compromised consumer routers on the internet. We've already discussed, such readily available proxying being used to hide connections back to command and control servers. In this case, it wasn't necessary to do that before. Now it is. So it'll happen. We already saw something similar with the adoption of package submission bots, which we were just talking about the other day, being used to create unique per package submission accounts. This prevented casual linkage to other malware, which had also been submitted by the same, maldoer. The underlying problem is that at the moment, and as Google referred to, saying it was crucial and necessary, anyone is able to offer packages for submission. There's no reputation system in place, and the problem with reputation-based filtering is that, yes, it can be discriminatory, preventing valid unknown publishers who've not yet established a reputation from contributing their efforts. So we still have some problems to solve. Nevertheless, it is wonderful that the inherent value and power of open source software and its need for some form of security oversight is being formally recognized, and that we now have an OpenSSF, an open source security foundation, which will focus and work towards introducing improvements in this valuable ecosystem. And again, if anybody is looking for something to contribute to, something, some way to apply their skills, I think this is great because, the the gotcha here in the whole OSS movement is that security is as big a problem there as it is for the closed source world.